So this shuffling technique is called a Faro In-Shuffle, named after an old card game called Faro, and the in-shuffling refers to the fact that the outside chips will become inside chips. Or more precisely, the top chip will become second from the top, and the bottom chip will become second from the bottom. So if we just see one version of that, we can see that the top chip is now second from the top, and the bottom chip is now second from the bottom. And all of the chips are alternating perfectly. Okay, so the question is, if we do repeated Faro In-Shuffles, will the chips ever return to their original position? And if so, how many shuffles does it take? So let's try the case with 10 chips. 1, 2, 3, 4, 5. Okay, after 5 shuffles, all the reds are on the bottom. It's reasonable to assume that after 5 more, they'll be back on top. 6, 7, 8, 9, 10. Okay, so yes, after 10 shuffles, all the reds are back on top, and each individual chip is in fact back in its original position. Okay, so 10 chips required 10 shuffles. So let's try the next case, which would be 12. We always want to do an even number of chips so that the two halves are the same size. So let's count. 1, 2, 3, carefully, 4, 5, 6. Okay, after 6 shuffles, all the reds are on the bottom. It's reasonable to assume that 6 more will bring them back to the top. 7, 8, 9, 10, 11, 12. Okay, so yes, indeed, after 12 shuffles, they are all back in their original position. Okay, so 10 chips required 10 shuffles, 12 chips required 12 shuffles. So care to venture a guess at how many shuffles will be required for 14? Well, let's find out. 1, 2, 3, 4, and wait a minute, all the red chips are back on top already. And yes, indeed, all of the chips in this stack are back in their original position after only 4 shuffles. Okay, so again, 10 chips required 10 shuffles, 12 chips required 12 shuffles, but 14 chips only required 4 shuffles. So what's going on here? We can keep trying the higher cases like 16 and 18 and 20. Eventually it gets kind of hard to do the shuffling. But the question is there an actual pattern that's going on here? And if so, can we come up with an explicit formula to describe that sequence?